My name is David Glick, and I'm a consultant. I work with Jazzcarta and Oddbird and do some things on my own. I'm very excited to be here in Barcelona because this is my 10-year Plone-iversary since I started working with Plone in 2007. Nice to see you all here. This talk is called Nice Blobs. Be a shame if anything were to happen to them. And it's a talk about an experience that we had moving a large number of blobs, mostly images, on a site to cloud storage, and how we went about doing that out of the ZODB. You're going to hear me say S3 a lot because we did use Amazon Web Services, their S3 storage product. But if you're not able to use Amazon, I think you won't be able to use the specific code that I wrote, but you may be able to use a lot of the same principles to build something very similar for a different cloud storage provider. This is an image from the site that we worked on. Washington Trails Association, WTA.org, has a site where if you're in Washington State, you can go there and learn about where to go hiking. They've been around for 50 years, and they promote hiking and outdoor activities. They do a lot of work doing trail maintenance in the state. And they have this site where one of the main features is that if you're going hiking, you can log on to your profile on their site or in their mobile app, and you can upload your own photos to a trip report that describes where you've gone hiking, what the state of the trail is, that sort of thing. So as a result, they have lots and lots of images. In May of this year, when we were facing this problem, they had about 650 gigabytes of images, and that was growing by a few gigabytes a day. And the disk on the server where those images were stored was about 98% full, and we were trying to figure out what to do. And you know, problems with this, of course, you have to keep taking the site down so you can resize the disk so that it can hold more blobs, and we were tired of doing that. It also meant that it was hard when we were working. We just did a big upgrade of the site, not to Plone 5 yet, that's coming, but to Plone 4.3. And we had all these blobs that we wanted on the staging server, but that's a lot of data to move around. So that was difficult. And then also difficult to deal with backups. We have an offsite backup that copies those blobs to a server on a different provider, but we only have one of those. We don't really want to deal with moving that much data to other servers, so the staging server was actually on the backup server, which didn't have as much power as we would have liked. It was limiting us in a number of different ways. So as we started looking at how to solve this problem, we had various requirements. We wanted to move the data to cloud storage of some sort. Amazon was the obvious choice for us just because we use it a lot for other things. We wanted to keep reasonable performance. Moving to cloud storage means that there's probably going to be more latency in loading files. We wanted to make sure that that wasn't really going to impact the user experience of somebody using the site. We wanted to make sure that it didn't change how Plone worked. If there were custom code or add-ons that were working with images, we didn't want them to have to suddenly use some different API. We wanted this to be as transparent as possible to them. And finally, we wanted a smooth migration path. So we wanted to be able to make the switch gradually. We didn't want to have to take the site down, move all the blobs, and then bring the site back up. So I'll talk a little bit about some of the things we considered for how to solve this. We thought about handling it at the app level. So we thought about just, let's take the image content type, let's add a new field, which is storing an S3 URL. And then let's arrange to have a job that runs after you upload an image. It'll copy it to S3, write to that field on the object, and then delete the local copy of the file. But then we started thinking about how images are actually used in Plone, and we realized that it's not just getting the full copy of the image to display it to the user. You also need it if you're going to generate image scales. You also need it if you're going to figure out what the dimensions of the image are. That actually reads the file and looks at the header and figures things out. And we realized that we didn't really understand all the places that Plone might work with images. What do add-ons do with images? So we really kind of ruled this out pretty quickly and started looking at what can we do at the ZODB level. pretty quickly I remembered that Zio has a cache of blobs. If you've got a Zio client running on a machine and it's connecting to a Zio server, it'll fetch blobs when it needs them from the server. It'll put them in a local directory on disk, and then it'll open up the file and use it from there. So I figured maybe it wouldn't be too hard to modify that and say when you would go get it from the Zio server, we could also add a step that would go get that from cloud storage. And also, we have this directory that there's already code in Zio that manages the size of that directory. It keeps it from getting too big. You can configure how big it is. Great. So maybe all we need to do is modify that. And as I looked further, I realized that actually our old friend Jim Fulton had already created a thing that did just that, S3 blob storage and S3 blob server. He built this while I was at Zope Corporation, and it's sort of what I just said. It replaces the Zio client storage, so the piece of ZioDB that is in the client. It replaces that with something that's it's just a subclass that changes a few things so that it will actually download blobs from a URL that's configured. But as I looked at it more closely, I realized that it wasn't going to work great for us. It really seemed kind of experimental. There wasn't much documentation on how to use it, which isn't necessarily a deal breaker, but it means you have to look at the code more carefully. The thing that I was really unsure about is it uses this separate process called the S3 blob server that actually deals with fetching the things from S3 and serving them to you. And that thing is written in Scala, which I don't know anything about Scala. I didn't really want to learn about Scala or how to deploy it. So I looked at the options more carefully because of that. And also it assumes that you're configuring the location of that server using Zookeeper, which is something that does get used. They used it at Zope Corporation, but we weren't using it. So I came up with something that is a variation on a theme. It works a little bit like this. It's called collective.s3 blobs. And what it is it's this S3 blob cache that lives within your Zope client process and takes care of figuring out where to get the blob from. So the first place it'll look is the ZioDB. Either with Zio or without, it'll go load the blob like it would normally if it's there. If it's not there because you've moved it elsewhere, then we will look in a new file system cache that belongs to S3 blob cache. If the file isn't there, it'll get it from S3, put it in the cache, and so it can load it from there as the file is used again and again. And that cache works similarly to the one that's built into Zio. The last piece then is this archive blobs script that you can run whenever you want. That will take the blobs that you want to move from the ZioDB into S3, move them there, and then delete the local copy. So as soon as it's not here locally, it's already in S3, and then things will flow from S3 into Zope instead of from the ZioDB into Zope. So we're prioritizing local storage. We're trying the ZioDB first. That's great because it means that as you're making changes to your Plone site, those are just getting written the same normal way into your ZioDB and will be accessed from there. And also, your local or relatively local file system is presumably a more quick way to load that data. And then, yes, secondly, we'll try to fetch it from S3 and cache it, so if it's getting accessed frequently, we don't have to incur that cost every time. Like I said, that cache, we're actually reusing a lot of the code from the Zio client cache for blobs. So it has the same properties of, you can say how big it should be, and it will run a thread that cleans it up periodically to make sure it doesn't get too big. Also, that cache, it's just a file system directory that holds blobs, so it can be shared between multiple Zio client instances if you have a bunch of instances running on the same machine. And also that cache is only holding the things that come from S3, so you aren't duplicating, wasting disk space just to deal with serving the things that you can get locally. So this archive script has various properties you can pass to it. You don't have to move all of your blobs to S3. This command here, A is age, so this is saying move any blobs that are older than 1 day, and S is size, so it's move anything that's over, about 2 megabytes. And D is whether to actually delete it locally or not, which, you're generally going to want to do, but I used that flag when I was developing the thing to make sure that it was working. So this gives you a fair amount of control, so you can prioritize fast local access against lowering your disk use and figure out where the right balance is for you. And like I said, when you create a new file, it gets accessed normally until you run the script, so you can wait a couple of days, make sure that all your image scales are generated or whatever, and then you can move it to S3. And finally, this means that you don't have to move everything at once, so you can do a progressive migration. Like when we rolled this out, we first did the very largest files just to make sure that it was sort of working, and then we sort of went from there. To configure this thing, you write something like this in your build out, which ends up generating the S3 blob cache section, which goes into zope.conf. So, the S3 blob cache, it has a cache directory, which is where do you want to put the blobs that are getting loaded from S3. It has the size limit. It has the name of the bucket that you want to get the blobs from. It's also actually making use of your Amazon Web Services keys, which are loaded from environment variables. And then there's this %s. %s is whatever ZODB storage would normally be in use. This is actually a feature I added to the Zope 2 instance recipe for build out so that you can wrap your normal ZO storage or file storage with something else that modifies it. So this thing is actually operating as a wrapper that proxies access to your underlying storage. So you have your S3 blob cache, and it can talk to client storage, which talks, is part of ZO, so that talks to a ZO server, or it can just talk directly to file storage and get things directly from the disk. This can be really nice for local development. So you can point your local copy of the site where you're making changes at the same bucket that has the blobs on S3, and you don't have to deal with copying anything. It'll just fetch things as it needs, and it's read-only, so you don't have to worry about overwriting things with your staging data. Any changes that you make are just going to get written to your local blob directory, and you don't have to ever run that archive script on your development copy of the site. So this thing is working pretty great. We moved, like I said, gradually decreasing sizes of files. I think we got down to 1 or 2 megabyte files that we moved, which was something like 50 or 60% of their disk usage. And I had a hunch when we started that most of those files were going to be like the original size images that people uploaded to these trip reports, which we aren't actually really using very much on the site. I've tried time and time again to talk them into limiting the size of the files that people upload to the site, but they have good reasons for wanting the original sizes so that they can, print out poster-size images of the beautiful scenery that I'm showing you some examples of. So anyway, they got lots of large files that aren't actually accessed, which means that, at least in this particular site, a lot of the data that we're moving is only infrequently getting moved back into the cache and accessed. So that means in this case, there's not much impact on performance. Most of the images that are actually served are still thumbnail versions that are served locally. And it's also low cost because we aren't actually doing a lot of data transfer out of cloud storage. So of course, your mileage may vary with your site. But it worked really well for this sort of big archive of images. I need to talk about some caveats. Bucket security, how do you make sure that once you've got your blobs into S3, they aren't going anywhere? We're relying somewhat on just the durability that S3 claims to offer. Amazon is presumably not storing just one copy of the file. I was more worried about user error. What happens if somebody who has access to the bucket via the Amazon console clicks on the wrong thing and suddenly the bucket is gone? So we actually figured out that we could set up a special security policy for the bucket that basically says nobody's allowed to delete it. You can, delete the policy and then delete it, but it's a barrier to prevent the accident. You can also enable versioning on a bucket in Amazon S3, which helps with changes to individual files. Like if something happens, if a file accidentally gets deleted, there would still be a copy that you could restore in some way. And we also thought about just backup strategies. There's another feature of AWS, which is you can take a bucket and mirror it to a different region of AWS, so that like if one region has some catastrophic failure, you would be able to switch over to the other one and have a reasonably up-to-date copy of your blobs. And finally, we haven't bothered to do this, but if you're worried about just the viability of Amazon or something, you could, of course, copy your data to a third party. And I haven't written a script that will, read through your bucket and pull all the files down, but that wouldn't be a terribly hard thing to do. There's a few more things that I haven't implemented that I think would be useful additions to this tool. Packing is something that you can still do to your ZODB. It'll work just fine. What it won't do is the blobs that you've moved to S3 and that only exist there, the packing isn't going to know anything about those. So it's not going to delete files from your blob storage on S3 that are no longer in use on your site. I sort of have some ideas of how to implement this. I mean, either you keep track during the pack of which files were referenced and are no longer, and then you can delete them afterwards. Or you can just scan through all the blobs in the bucket, try to load each one, and see which ones are no longer present in your data.fs. Another feature which we sort of thought at the beginning we were going to do, but we ended up not doing, was once you've got the blobs in S3, you can actually serve them directly out of Amazon's CDN, which is called CloudFront. You just point to a particular URL, and then it'll so this actually does require some app level changes. On your view where you are displaying an image, you would have to find out what the correct S3 URL is and use that in that view. We didn't end up doing this because of some particular considerations for this client. They already had data transfer that was included with their hosting package, so that there was no particular reason to switch to something where they would have to pay separately. Matthew also pointed out that there's security considerations. You need to make sure, in this case, all the images are public anyway, so it didn't really matter if we're making them publicly available, but that's certainly not going to be the case for every blob and every site. So this is another thing that we didn't build for WTA, but it could probably be added on for somebody else's use case. So finally, to summarize the status of collective.s3 blobs, it's in production use, it's stable. It's not released, mostly because I've been busy trying to fix bugs in ZOP 4 this week. It's within easy reach of a release. It needs but it has some documentation. It needs more documentation. It needs more tests. But it's a tool that I don't feel bad about recommending to people. So yeah, that's collective.s3 blobs. I'm happy to take any questions. I think we have a little bit more time. Yeah.
Does this assume that there's a single ZOP front end? Because it seems like with a cache here, if it isn't like right through cache, if you make a change on it, it doesn't get propagated out of cache 3, another user on another front end wouldn't see the changes, might also edit it, or if you're behind a load balancer, would get a different version from a different front end server.
The question was, how do you make sure that when you're writing changes and you've got multiple ZOP instances that they all see the changes? This doesn't actually affect writes. It's not a write-through cache. Well, I guess maybe it is. But the writes go into the ZODB, and the ZODB is the first place that all of the clients are looking for loading things. So it looks in the ZODB first, then it uses the file system cache, then it gets it from S3. So I don't think that's a problem.
It's a two-part question. The first part is, since you said there's a no-delete policy for the
So your question is, what happens when the user deletes a folder that has images? That was the slide where I talked about packing. So normally in the ZODB, you do a pack, it figures out, oh, there's these blobs in the database that are no longer referenced from anything, so we can delete them from the ZODB storage.
Yeah, but what about S3?
Yeah,
S3, is there a garbage collector?
there isn't right now, but it could be created pretty easily. Yeah.
Does your preview server use a copy of those blobs, or do you just point that's the original blobs because they don't change at all actually?
The question is, does our staging server, where we're working on things, point at the same bucket, or does it use a copy? We haven't actually done any large-scale work on the site since we rolled out this, but yeah, I would anticipate that we'll probably point it at the same bucket, and then any changes to the blobs that happen while people are working on the staging site will just get written into, we'll still have a copy of the data.fs, so they'll get written to the local blob storage, but we won't run the script to modify the bucket on S3. So yeah, they aren't changing once they're written generally.
Have you thought on the need of implementing this archive tool that you have in the CLI? A way of not only archiving by date or by size, but also by popularity. Like for instance, if you have images showing in a homepage, maybe you're in a situation where today you send it, then it gets hit.
Right. The question was, can the archive script, can it, in addition to paying attention to size or how recently the blob was added, can it pay attention to popularity, how frequently it's being accessed? I don't really know how we would know which blobs are popular. I mean, the blobs are fairly opaque as to how they're actually being used in the site. But what does happen is if it does get moved to S3, it'll end up in the cache and presumably stay around in the cache because it's being accessed. Although I won't make any promises about the details of that cache because I need to go look at the code again.
Is it used for more than images?
Is it useful for more than images? I think you'd have to think about how the files are being used and estimate what your costs will be in terms of how frequently things will actually be getting loaded from S3. But yeah, I mean, I think it has the potential to be. I mean, there's some like large PDFs that I'm sure are included here too. Any more questions? Feel free to find me afterwards. Thank you very much for coming to the talk.